Carlotta, and yesterday we are discussing HbbTV privacy invasiveness across European countries. So I had a talk on Wednesday, but I'm not sure if all of you attended, so I will just briefly recap what I did. So this is an example of banners that are presented while watching smart TVs, and they usually come in the format of press the red button, be interactive, do a bunch of things. And so if it has ever happened to you, I mean, it's a European protocol, so I think I'm just referring to European persons or people who live in Europe. If it has ever happened to you that you've seen such banners, it means you have experienced HbbTV. So, which is a initiative that dates back to 2009 when a German group of industry leaders decided it's time we find something to keep the television at pace with new digital media such as Netflix, because they realized that TV was being watched just by elders. And they said, we need more interaction, we need new feature for it. And so they came up with this protocol that utilizes two different connections in parallel: the standard, the usual broadcast network, the DVB network, and an additional network that is the broadband communication, which is internet connection. Yeah. And so the HbbTV application are URLs that are embedded in the broadcast stream that are delivered to the smart TVs, and such URLs are then extracted and loaded in the built-in browser of the smart TV. So they appear as transparent graphical overlays on top of the standard TV program, and are developed with standard web techniques such as JavaScript and HTML. So the architecture is quite simple. We have the two connections, broadcast and broadband. The peculiar thing of broadcast connection is that it's just unidirectional. So the broadcaster can communicate with the smart TV, but then there's no way for the smart TV to communicate back to the broadcaster. And this is why also the broadband communication is useful, because it's bidirectional, so data can go in and can go out. We perform our analysis across 5 European countries, them being Finland, Austria, Germany, France, and Italy, for a total pool of 36 channels with different content offered with from different broadcasters. And so, just briefly, our results in terms of privacy and security invasiveness show that 26 channels communicate with trackers before the user has expressed their consent. And even 7 of them do not even have a privacy policy banner, or just do not let users decide what to do with their data. In Austria, all the 4 channels communicate every second with a tracker. And also we found an interesting technique, which is called tracking pixel, which consists in uploading a 1x1 pixel image, which is transparent to the naked eye, and that gives broadcaster useful information such as what program is being watched or what functionalities are accessed by the user. And even more worryingly, I can say, there is a German shopping channel, HSE, which allows user to purchase things and create accounts all over HTTP, so over plain text. So credit card data, account information are all sent to whoever wants them. So now let's get deeper into the more methodological part of our study. Our testing equipment consists of 2 smart TVs. So a Xiaomi Android-based smart TV and a Samsung smart TV. And the reason, technically just one would suffice, but there are some applications which only work on the Samsung device, and this is something we're currently exploring because we cannot really find reason. We have access just to the client side of the application, and there are not really errors that justify this misbehavior. Then, a laptop, clearly. And also we additionally had an antenna and high-des modulator. So our need for the modulator is because we need to analyze the signal on a laptop. So we need to somehow get the signal and modulate it in a way that it can be readable. And we chose such a modulator because it's supported by Unix system. And yeah, I reported there the URL of the page where it can be found, even though it's mostly just available on eBay. So yeah, we have developed a two-way testing methodology. First, we recorded traffic directly generated by the smart TV. And in the second part, so on TV testing, and also we decided, well, I mean, let's try to see what information we can get from the signal. Let's extract the URLs to the application, and let's capture traffic from there. So let's start with the on-TV traffic testing inspection. The main problem we faced was encryption, because of course, just listening to the traffic with Wireshark, we faced a lot of DLS, and we decided, well, how can we bypass encryption? So our first idea was to proxy all the TV traffic, all HbbTV traffic, but proxy settings of TV do not apply to HbbTV traffic. So we wanted to directly make the TV trust the cell sign certificate of our proxy that we decided to run on the television itself. But to write the certificates in the television, we needed root access, because the location where the certificates are located, it's protected. It's with root privileges. And here the problems began, because we tried to find a custom recovery image for the TV, but couldn't find it. So the first option, so using Magisk and custom recovery, in our case TVRP, it was not an option. We then tried privilege escalation with Metasploit, but the version of Android was still too recent, and there were no active exploits for it. We also tried to unlock the bootloader, but for some reason, every time I tried it, the TV would shut down. And so after I broke one television, I decided, well, I mean, let's skip this step. And we decided, so that's why we came up with the second methodology, because we decided, well, I mean, we cannot just waste off television. And we extracted the URL directly from the DVB stream, which sounds much easier. And so, yeah, as I said before, what we used is this high-des modulator, a small antenna that can be purchased anywhere. It's like just a regular antenna. And TSDAC toolkit for manipulate MPEG transport stream and parse the streams we got. So the model of the modulator we use is QT100C and supports DVB-T to terrestrial, which is what we focused on. So we didn't inspect DVB-S, which is satellite. And it allows for both transmission and reception, but we just wanted reception. It's powered by the USB bus, and no host CPU computation is required, because everything is performed on this kind of USB stick, let's say. And the price is also quite reasonable. It's like around $150. Not that much expensive. And so what how to get the traffic and how to get those URLs. So first we needed to find the ultra high frequency of the channels we were interested in. And this can be done via this modulator by just running a scan of the entire frequencies and find where the channel sits. Then once we got the specific UHF, we capture traffic for 100 seconds, but that's just like a custom value. It can be anything. Then we get the streams, and from there we extract the application information table, and I will later go deeper into what this application information table is. Of course, well, I mean, we converted everything in human readable format, but it could be also captured as binaries. Then we open the files, extract where the files where this code, HbbTV code is, and got the URLs. So this is how the stream converted into TXT looks like. And on top we have the service name, so the broadcaster, the channel we are analyzing. And then we have a bunch of programs, chunks, which are audio, video, teletext, and application information table. That is where HbbTV lays, let's say. If we then decide, there are on the left, there are the program IDs, and if we use them to extract those specific chunks, we get something similar. So we get this file where the application information table is reported, and there are two important fields for us, which are URL base and initial path, that combined together make the HbbTV application URL. So we repeated this process for the 36 channels and got the, not for all of them, but we got the URLs in this way. So yeah, there are a few challenges we faced. First of all, our antenna was not strong enough to capture all the broadcast signal for all the channels. And some countries only adopt cable signal. And so we only were able to capture the broadcast signal for the channels using the antenna signal, so air transmitted signal. Also, some countries, for example, Austria, deliver the streams encrypted, and you need a specific module that you have to insert into your smart TV to then decrypt it, which is also another challenge we faced that made this process not really doable, let's say. So yeah, in the end, we got 24 channels, 24 application. And this method will also help with reproducibility and flexibility, because the research for future researchers do not have to be in the country where the specific channel is aired, but just can open these URLs from wherever they are. So yeah, got the URL, open them in the browser. The two main things we did to make this work is change user agents to the user agent of the Smart TV. And in some cases, we also had to use a Smart TV browser emulator, which binded the right key events. So for example, the red button, the green button, which are not present on the keyboard of the laptop, and also simulated an embedded broadcast signal in case some application were requiring for it to correctly functioning. So here are some examples of how HbbTV application looks like. Those are screenshots I took from my laptop. So yeah, for example, bottom left, the gray rectangle should be the actual broadcast stream, but since I'm using a laptop, I'm not getting the broadcast stream. And so first we captured all the traffic, both from the on-TV and off-TV inspection, in 4 phases. The first phase was before consent, so before accepting the privacy notice about data treatment. And according to specification, no communication should take place. Nevertheless, especially not with trackers. And so, yeah, this is the first phase of our testing. Then we decided to interact with the application. So we accept if there is any privacy policy, and interact with the buttons and explore how the submenus of the application. We then revoke the consent to the privacy policy if present. So in this case, cookies must be deleted and tracking must stop. So we did that to understand how the different broadcaster handled whether a user decided to deny treatment of their own data. And finally, we give such consent again. And we do this just to understand if cookies that are set are the same or are different from phase 2, let's say. we replicated this approach in every country and every channel we tested. Then we'll briefly go how we inspected the traffic files, but we capture pcaps and we use T-Shark to extract the relevant information, which for us were domain name, the testing phase label, so either before consent, after consent, and then other information like the number of requests, whether the requests were using HTTP or HTTPS, and cookies or return objects. So where does automation come in the game and where we needed manual effort? So of course we tried to automate as much as possible. And so we precisely time the capture phases via Barshark. And we extract automatically all the domains from the pcaps, basically looking at the DNS information. But automation is not always possible because we try to automatically match the domains we extracted with well-known tracking deny list from Piol, EaseList. But we found out that they are not complete for the Smart TV ecosystem, so they miss a lot of trackers. And so we had to manually label all the domains and see what type of function they serve. Also, the automation with HbbTV apps was done manually. First of all, we don't have control of the built-in browser of the Smart TV unless we could extract it from a firmware and then modify it. And so we manually interacted with them, and also to avoid, let's say, automation problems which are unexplored path. So, we might also have unexplored path, but we try to be as comprehensive as possible. And this concludes the more technical effort we did. In addition to that, we also surveyed users' awareness of privacy and security risk with Smart TVs and HbbTV. We followed the ethical guideline defined by the University of Twente and also received approval from the IRB to perform our survey, which we conducted on 174 participants. And as we followed best practices, so we put our contact information on the first page. Participation is voluntary, so if users want to drop out, they can just send us an email and said, well, delete all my data. But anyway, the survey is anonymous, so we don't reveal anything about the users. It's just more about the privacy behavior, let's say. We also used a European-based platform, which is based in Munich, and all the servers of this platform are located in Germany, so subject to GDPR regulations. And the other good features of this platform are that it allows for high customization, so we can select random orders or shows questions us if others are completed in a more flexible way than what other platforms offer. And we adopted a mixed methodology, so we have both quantitative questions, so closed questions, and qualitative open-ended questions. We tried to simulate as possible an interview with the participants, and we also adopted an open coding approach to cluster the answers to those questions. I must say that it was really hard to gather participants because we didn't pay them. And so, of course, if people are not rewarded with money, are typically not willing to do anything. So, yeah. And I also want to mention that our analysis builds on top of a previous research work by Guilherme. They had a limited number of channels. They only analyzed German channels. And additionally, they performed analysis in 2013 when mostly HTTP plain text traffic was used. And so they didn't face the encryption problem we faced. But yeah, the general approach, let's say the 4 testing phases are the same to also understand how the situation has evolved in almost 10 years. And also the awareness survey is, they had a similar approach but more targeted on smart TVs rather than HbbTV. And they conduct the survey over German participants while we conduct a survey over Italian participants. So yeah, in general, measurement papers still tend to outdate quickly. And also, I must say that there was a shift towards HbbTV 2.0 over the past 4 years. And so this should increase the security of this protocol. It didn't, but it should. And so we wanted to understand what differences the new protocol version brought. As I said before, there is the German channel that still, after 10 years, did not fix the plain text communication of credential yet. So open challenges we have are bypassing encryption when capturing on-TV traffic. So either being able to route a smart TV or find a way to install proxy certificate authority. Another interesting challenge is extract URLs when no antenna signal is present. I had a talk, a few days ago with a person from ESC, the European Space Agency, that suggested me a very cool setup that I will probably test it out. And better understand why some applications do not totally work on the browser environment when we try to mimic the smart TV one. And finally, we also would like to gather more participants, maybe paying them, to avoid some biases we might have introduced in the selection of the participants. So what's next? We are trying to disclose. We are still in the disclosure process. Now I have contacted 4 national certs and got no answer. So, I mean, it's a process that takes time, but at some point, if this way doesn't go right, we might try to go at the European level and try to contact directly them. But so far, we got no answer. And so another future step would be try to test other countries and other channels. And again, investigate this Android Samsung incompatibility and find out what the problem is, because it's, I think, an interesting peculiarity. And see if there are similar protocols adopted in other regions, because, as I said, this is a Europe-wide protocol that it's, starting to gain traction in other countries as well, such as Russia or Vietnam, but mostly focused in Europe. And we're interested to know if there are similar protocols for public television that are adopted outside of Europe. So yeah, this concludes me talking. And now, if you have questions.
Thank you so much for this presentation. It was really interesting. Just a question regarding disclosure process. Did you also disclose to the channels? Because in the end, they provide the website, I guess.
Yeah, so when we could find an email address, we did. For some channels, we couldn't. So yeah, we sent them an email. We got, I think, one reply back that just like the automatically generated one. Oh yeah, thank you for your issue. We are looking into it, but
okay, yeah, fair enough. For Germany, I know the BSI, so Federal Office for Information Security, might also be quite interested in this. Okay. So we had always good contact with them. So if we had something to disclose.
Okay, I have not contacted.
Yeah, we can talk about this offline. Okay. So they
sure.
Quite helpful.
So far I contacted certs in Italy, Austria, and the Netherlands. but not yet in Germany. But might be a next step. I mean, at this point, let's go for every country, I guess.
Again, great talk. From the US, this is all new to me. I did not know that HbbTV was a thing. Does it send identifying information in the web requests? Is it simply, I am watching this TV show and I clicked a button, or is it someone is watching this TV show, clicked a button, and it is this unique person or this unique TV set that is transmitted?
Yeah, so the way it works is usually individual based. So they give you a visitor ID, and so that is unique to you. Then of course usually it's not shared across broadcasters. So it's just one broadcaster that knows, okay, this user is watching this channel, is interacting with this functionality, is mostly interested in football and politics. But of course, this does not mean that there might actually be communication among broadcasters. And also the important thing to notice, I'm not sure how it works in the US, but in Europe, mostly like a single broadcasters own different channels. So like this visitor ID is not set for a specific channel, but for a broadcaster. So the broadcaster has access to whatever the user does on all these channels. And additionally, in 2020, so pretty recently, there was an extension to HbbTV, but it's still rolling out, where they want to use HbbTV to also deliver targeted advertisement. So with the information they gather from what you watch and what to interact with, they're planning on overlapping your actual channel, so what you're watching, with this. They call it L-shaped adverts because they're L-shaped, and that are just targeted to you. And of course, like there's also channels that use bigger tracking services, such as Google Analytics, for example. And then this also means that Google Analytics has access to whatever the user is doing, even across different broadcasters.
Did you try manipulating the visitor ID and sending a spurious one to request did you try sending a fake visitor ID to request the URL and see what happens?
No, actually no. We just collected traffic, but did not reply back. But that's an interesting point. We might actually try to play around with them a bit. But I know that that's also an issue because previous papers also focus more on this spamming fake analytics to kind of manipulate what the broadcaster wanted. And this might also, they didn't go that far, but this might result in programs being dismissed because maybe like the user said, oh, well, I really don't like this. And it's about, they have an interest in being watched. So of course, like if a program is very much disliked, then they will dismiss that.
Hi, great talk. I wanted to come to your fourth point. So this the button pressing and the interactions reminds me a lot of the stuff that I saw back in my home country in Japan. Mm-hmm. We've been adopting this for a very long time as well, probably over 10 years as well. So it might be worthwhile to look into that as well. But obviously, because it's so far away from Europe, I don't think you can capture the signals from Europe. But yeah, if you have a collaborator from within Japan, it might be interesting as well. Because I've definitely used it before because there's like this very famous TV show that we can vote for a team whether we like it or not. And we use the exact same system. We pressed a red button for one team and then like another different button for the other team, and then that would then mount up. And I was always wondering, how do you know that this is like unique? So probably there has to be some sort of identification system, and this kind of sort of your presentation sort of like gave an insight on how there might be using that information.
Do you by any chance know if this application is I guess it's so you have aerial DVB, aerial broadcasts or cable broadcasts or.
So I just looked it up right now.
Okay.
So we converted from like an analog system, broadcast system, to a digital broadcast system in 2012 or something, like maybe a little bit before than that. But that's when we started to see this. Like, you know, like the HBB thing. But it seems like the European protocol and the Japanese protocol are completely different things. Okay. So that might be, you know, a big challenge for you to investigate.
No, I mean, but yeah, that's also what we were talking with the person from the European Space Agency, that it might, if we get access to satellite signal, we might also get access to more channels across the world and not just where we reach terrestrial DVB, but yeah.
Right.
So like that could also.
Yeah, so there's this Japanese national broadcast system called NHK. NHK does have satellite broadcasts, and I've seen it here in the United States. I don't know whether I've seen it in Europe, but you might probably be able to capture those signals over the satellites.
Okay, thank you.
So I've got a quick question. Maybe I just wasn't paying close enough attention, but I didn't quite understand the challenge you ran into the encryption with the on TV that forced you to go to the off TV that still allowed you to extract the URLs despite the encryption. So why is it that you didn't run into the encryption problem off TV?
Off TV, we didn't run into encryption programs.
Right.
So just on TV. So the.
Can you go back to the?
Yeah, sure.
I'd like to better understand what the differences were between those two.
Let's go here, I guess.
Yes.
So we try. So the main problem is that if like we try to proxy all the traffic of the smart TV to the laptop, but HbbTV is not subject to proxy rules. So we couldn't proxy all the traffic. So our idea was, okay, we'll just put our laptop as a man in the middle, let's say, between the smart TV and the internet, and capture traffic there. And of course, the traffic would, even if we set a proxy, if we were listening, we would face encrypted traffic because the smart TV and the internet communicated over HTTPS. And
so in the first scenario, the on TV scenario, where's the encryption occurring? Is it the DVB signal that's encrypted?
No, the DVB signal is not encrypted. It's the HTTP level.
That's my answer.
Okay.
Thank you.
No, the funny thing is that, actually the DVB stream is not encrypted at all. So that's also why we could extract the URLs, and why DVB injection attacks are also very successful, because a malicious user can replace HbbTV application URLs and just show the consumer with whatever they wanted, because then there is no way to certify that the application that is being delivered is actually the legit application. And if you can replace the legit broadcast stream with your own one, for example, with a strong enough antenna, then you can do whatever you want with the consumer's smart TVs.
Were you able to make any artifacts from your work available for others?
Yeah, so I'm cleaning up the code, but it will be up very soon. So we're still discussing whether to make all the pickups available or not, but I guess there are not big problem with that. But yeah, I mean the last slide was actually the link to the GitHub repository where we will release soonish the code.
Great. Thank you.
Thank you.
Laura, I don't see any other questions in the... I do see one more quick question.
I know you had mentioned doing your survey, and you mentioned you had problems getting a lot of recruitment and everything. I don't know if I might have missed it. Where had you tried recruiting, and when you were doing your recruitment, how did you kind of like advertise it, and what were you saying that the survey was about to try and get that sort of participation?
So I think the biggest problems we had is that we made the survey actually a bit too long. And so we had a lot of people dropping out after the first 2 or 3 questions because the URL was actually received by around 1,000 participants, but then just 174 totally completed the survey. So the way we spread it was over social medias, and we just joined a bunch of random groups on Facebook and posted it there of people that I don't know and that were like quite generic. But yeah, I mean the lesson we learned is that we cannot pretend too much. I mean the survey, if you completed it, took around 15 minutes, but I guess that was too much for a participant that had no reward in doing it in a way. So yeah, that's the main issue we encountered with our survey. Was not really about like reaching the perfect number, was making people finish it. The main issue we had.
I don't know if you like had done this. One thing that we've always like put on our surveys is give them the estimated time of like this should take so much.
It was there, and but
we always go whenever we pilot it, we always put down like usually what the slowest time someone has completed as like that. So whenever anyone finishes below that, they feel better about it.
Okay, we didn't think about it. We in the first page was like we reported the estimated completion time, but not like, oh, hooray, you finish it earlier than the other people.
You just don't want to risk scaring people away thinking it's going to be too long. So I think we don't have any other questions in the room, Laura. We've still got a few more minutes if you've got any topics you want to explore.
Yeah, so actually you asked my question about the artifacts, and I was particularly interested in the data. So it sounds like you guys are looking into that. You think there's no privacy issues, right? Did I understand that correctly?
Yeah, so mostly looking into privacy issues, yeah.
No, but within the data that you collected, if you're to share that, would you be able to share it? Are there privacy issues in sharing the data you collected? Have you thought about it? That data might be useful to others?
I mean, the data might actually be useful to others, and we also, I spoke with the person who was doing automated traffic blocking rule generation that was interested in the data as well. I need to think about it, to be honest, whether we can. I haven't really thought about it. I mean, I don't think there are privacy issues, but the problem might be for the broadcasters since they haven't yet fixed the issues we encountered. So we first wanted to receive an okay from the broadcasters, but we'll never receive that. And then we'll plan to release it. But I mean, if it's like confidential, if it's something that interests researchers, we might share the data with them and not publicly disclose it.
So you had said you had approached certs, and I forgive me if I don't recall you saying, did you actually approach the broadcasters directly?
Yeah, but got just one answer back. That was automatically generated. So
that's useful.
Yeah. Yeah, I mean, it's still a work in progress that we're currently trying to conclude, but it will take, I mean, I hope it would take less time, to be honest.